Hey guys, it's Raz. All right, so today we get to talk about meat production methods. So, as you guys saw in class, it takes considerably more land for your diet if you eat a lot of meat based products. So, we're going to get into kind of part of the reason why, but also look at in our country how meat is raised. So CAFOs stand for Concentrated Animal Feeding Operations. They're more commonly known as feedlots. Basically, it's where we've got a lot of animals living in a pretty close, not pretty, very close proximity. They're typically fed grain in the form of corn, and the object is to just get them raised as quickly as we possibly can so that we can get them to processing. So we see a lot of CAFOs, partly, again, remember I said pros and cons to everything. We wouldn't have the diet that we have today if we didn't have CAFOs. But there's lots of, negatives to that as well. Positive wise, we maximize land use and profit. So we get the most meat production per unit of area with this, which means that for consumers, meat is less expensive, which means that we can get nutrition into people at a lower cost. One of the downfalls of it is that when you have this many animals living in close proximity, we tend to just kind of mass give antibiotics. We don't want them to get a disease. Outbreak would spread pretty quickly, so we kind of blanket them. That's led to a rise in antibiotic resistance bacteria, which is affecting everything that bacteria can infect. So that's a little scary. We also use growth hormones to speed meat production. There's not a ton of research about growth hormones in cattle and the effect on humans. But again, it's kind of it's raising them in an unnatural way. So a lot of people aren't super thrilled with that. Animals also produce lots and lots of waste. So that can contaminate the surface or the groundwater, especially if it's in a concentrated area. And one of the things we do is kind of store it in manure lagoons. I'll show you in a moment. Yes, you're excited for that. But the other side of CAFOs is any kind of animal, especially a ruminating animal, is going to produce a whole lot of methane. Actually, I used to joke that the leading cause of climate change wasn't humans, it was cow farts. That's not true. It's cow burps. It's actually neither of those. But the methane from ruminating animals is pretty considerable. And methane is a more potent greenhouse gas than carbon dioxide is. We also see nitrous oxides and carbon dioxide as well. So they're pretty big climate change contributors as well. In fact, there's been some estimates that if people were to give up meat eating for like a day a week, that it would be equivalent of taking like hundreds of thousands of cars off the road, which is pretty kind of interesting to think about. All right, so back to how we store the waste. So we have to come up with a way to kind of keep all of this waste somewhere. So they often will literally put them into large storage pits. Sometimes, if they're not super gross, like if we could do it the right way, we can use that for compost. But typically, these are creating way more waste than we can use in the area given. So they store them. Waste is going to give off a whole bunch of stuff, right? Ammonia, which is not smelly, it doesn't smell good. There's hormones in there because, again, we've put growth hormones into them. So there is the risk of those getting into groundwater supplies and soil, along with the antibiotics. And we often find quite a bit of bacteria, both fecal coliform and E. coli in those. If they flood, like heavy rain, that can run off into surface and groundwater nearby. So again, you get some of those things that are going to enter the system. So E. coli is very toxic to humans, not good at all for us. Ammonia can lead to eutrophication. And then again, you've got the antibiotics and growth hormones, which can alter the endocrine system of humans, so our hormonal systems. And again, we'll talk about that in class a little bit. There's some interesting studies on that. All right, so I mentioned here too that as that ammonia breaks down, it actually produces nitrous oxide, which is, again, a really powerful greenhouse gas. So we got that coming up. If we can do this right, a lot of that can be buried in landfills. It kind of goes back into the natural cycle. It's good. Or we can turn it into fertilizer pellets. The problem is that typically waste is looked at as waste for a lot of these CAFOs, and that doesn't always happen. So the other option is free range grazing, right? So it's allowing the animals to graze. Cows, for example, right, typically going to graze on grass, lets them grow at their natural rate. We don't use hormones. We don't use antibiotics because they're naturally spaced out. We don't really need them. And we don't need corn to feed them. We're letting them graze on grass, which is a much healthier option for them anyways. because they're moving and they're spread out, their waste gets kind of naturally dispersed over the land. We don't have this buildup. We don't need lagoons. It just kind of is more of a natural process. The problem is that we could not feed, at least if we all ate our American diet, we could not feed us with this kind of meat raising. We don't have enough space. You also don't get the profit, right? Because you need more space, it takes longer. So we have to kind of balance those things as well. So the meat would be considerably more expensive to the consumer. And you can even notice this if you go to the grocery store now. Like go ahead and like go back and look in the meat and you'll see, like different, they're marked as like antibiotic free or free range grazing or things like that. And they're quite a bit more expensive. The other benefit of this, it's kind of interesting, right? Is we talked about how a lot of our land we have to irrigate in order to be able to plant crops. Well, this would use land that is kind of naturally too dry for crop growth, like that we'd have to really irrigate, and you can turn it into grazing land for these animals because little, grasses and those kind of things that they would eat will grow pretty readily. We got to be careful if we do this to avoid overgrazing. So if we have too many animals in that area, either the grass goes away completely, so you're going to have tons of soil erosion, and you get a lot of soil compaction, which we talked about earlier. This can actually lead to something we call desertification, which can occur if the plants are killed, and basically that soil can no longer hold water like it needs to, and it more or less turns into kind of desert. So typically, if we have animals that are free grazing, they'll follow a pattern called rotational grazing, right? Where they let them kind of graze in different areas, and then they let the area that they're not grazing in kind of naturally regrow, and they move through. And you can kind of see this is also something to think about with grasses. Now, these are grasses that are cut like with a lawnmower, but it's similar to grazing, right? Same idea. And you can see the root structure when they're kept short and cut frequently to when they're cut more infrequently. And the root structure on those ones that are cut every 4 weeks is dramatically more robust. They run deeper. That's going to help stabilize soil. So lots of good stuff. So rotational grazing kind of also can keep those plants healthy. That's kind of what I just talked about here. Okay. Now, the other thing to think about is that producing meat really in a straight energy sense is really inefficient. We talked about that 10% rule way back when we did ecology, right? And we had said you get more bang for your buck to eat lower in the food chain. That is true, okay? So we know that the energy that goes in, right? If I'm thinking of meat, I have to plant, grow, and harvest what those animals are going to eat, right? And then I also have to think about water. How am I getting water to those animals, right? Am I housing those? All the energy that goes into housing them, the processing of those animals, right? All of that has to go together. And if you look at kind of the energy required to produce 1 pound, beef is by far the highest, right? Over 30 kilowatt hours per pound. So that's quite a bit, even compared to pork, right? Which is the next one, which is less than half of that. And you can see kind of the rest of the way down. So beef is our least efficient. And don't get me wrong, like I love a good burger and a good steak, but it's not very calorie efficient. Okay. The other thing is that we have to think about land, right? That's straight energy. But all of those animals need space to grow. So all of the energy needed to grow plants to feed animals plus the room the animals take up. Okay. So if you look about kind of the amount of usable protein per acre of farmland, beef is way down here. We're getting, 20 the complete proteins. That's what they're using as a unit. But we get 20 complete units of protein for beef compared to chicken at 45. And you can see kind of as we go up, right? Rice 265, soy 356. So vastly different there. Okay. And the other thing is that we have to also think about water. Everything that these animals take in, right? We've got to consider. And this little diagram is something to also think about and look at beef. So this is the liters of water that you need to make 1 gram of protein from each of these sources. Okay, so for beef, it takes 112 liters of water for 1 gram of protein. So if you're eating a burger that has 20 grams of protein in it, multiply that 112 by 20, and that's your one thing. That's a lot, right? And again, you can kind of look down. Now, I'm not making you do sample FRQs for these, but if I were, this would be something to think about, right? To think about an environmental benefit of eating a plant-based diet rather than a meat-based diet. Energy, land, and water are all important. And beef is at the top of the list for being inefficient for all of them, unfortunately. All right, so we'll talk a little bit more about some of this in class, but if you have any questions, please jot them and ask them when we get there. And until next time, kids, we'll see you later.